So suppose instead of using a battery for our power supply, we can use a variable power supply through this device that you're looking at back here. This is a DC power supply. And so what we have right now is we have the negative and the positive from the power supply, and we have connected that up in a series circuit with our two resistance boxes and also with our meter. Now if you notice, our meter is part of the series circuit itself, which means that the meter is poised to read current. So we're shooting for reading current once again. General rule of thumb, remember, is we want to start with 10 amps. But in this case, I've gone directly to the 200 milliamps, which is safe because if you start with the lowest possible setting for voltage, which you have here, you should not expect to be above the 200 milliamp threshold. Now the way you start, and the way you're going to start with using this power supply box, is there's also a switch, which is down here, for output current. The only thing you need to do with him right now is just make sure that the dial is turned just slightly up. Not much, just a little bit on. And it's the voltage which we're going to control. So we're going to control the voltage to our system. So let's take a look. So we can control the power. We turn on the power there, and we can see that we are supplying approximately 0.7 volts. So this isn't even the voltage of a regular cell battery. And if we take a look at our meter, we see that we're getting in the neighborhood of 9 milliamps of current. That is the electrons, the rate of the electron speed as it moves around the circuit. Now, take a look at what would happen if we increase the voltage by some amount. Just a little bit. Get my hand out of the way. Notice in this case, I've boosted the voltage to 1.3 volts, and in turn, that's boosted the current. So we think about voltage. One way to think about voltage is that it acts as a pressure. And what that'll do is that's going to push the electrons even faster, so the rate of charge that's moving about, which will give you your current, should also expect to increase. Meanwhile, all this is taking place for a given resistance. So resistance is fixed. So we're seeing another twist on how resistance and voltage or current are related to one another. In this case, the resistance remaining fixed, so we see a direct relationship. As we boost the voltage from our power supply, we see that we are boosting the current, and we could continue to do that. Try to put myself in a place so I can let you see both. Alright, so if I move in a little closer so you can see, increasing the voltage is increasing the current, as you see. Always being mindful that you do not want to increase beyond 200 milliamps.